Hello, RAP students. This is Dr. Smith here today. We are going to talk about exponents. So I hope you are ready. So we're going to go ahead and dive in, all right? So what you know more about, based on what we've covered, is multiplication. Multiplication, you can do something like 2 times 5. And of course, you can take multiplication and make it into addition, such as this could also be 2 plus 2 plus 2 plus 2 plus 2, because 2 is added 5 times. 1, 2, 3, 4, 5. Now, you guys already know that. And that comes up to 10, even if you count by 2s, 2, 4, 6, 8, 10. Well, you can also do multiplication where you, use an exponent for multiplication. But unlike up here, the exponent will be above the 2. And what this means is that you're going to do repeat multiplication, not addition. And so this exponent tells you how many times that you need to add this base number or multiply the base number. So you would go 2 times 2 times 2 times 2 times 2. And that is 5 times. Okay? Now, what you can do to add it together is you can put it in the calculator. But of course, we're not going to do that because that's just too easy right now. So we're going to add it like this. 2 times 4 is 4. And then 4 times 2 is 8. And then 8 times 2 is 16. And 16 times 2 is 32. And we get our answer. And that's how you do exponents, okay? So let's try another one. If we wanted to solve for 3 to the second power. That's how you say that, to the second power. So that means we're going to times 3. Another way that you can do times is with a dot twice, okay? So 3 times 3 is 9. All right? So if you understand how to do that, we're going to next try a problem, okay? The problem is, let me look and see what my problem is. 2 to the second power, so I'm going to put a number here just so we can keep it straight. 2 to the second power times 2 to the first power times 2 to the second power. Okay, now if we wrote this out the long way, we could do it like this. 2 times 2, because that's the number of times that we have to multiply. I'm just going to put parentheses around it. The next one is 2 to the first power. So how many 2's will we have? Just 1. And now let's go to the next one. How many times will we have 2? 2 times. Now, if you notice how I wrote this, another way that you can write multiplication is you can use parentheses. If there's nothing in between the parentheses, it's times, okay? Or if you feel you need to put something there, you can put a dot for times, or you can put an X like that, okay? Now, isn't there a shorter way that we can write this? There really is, because you can just do this since it's all multiplication. 2 times 2 times 2 times 2 times 2. How many 2's do we have? 1, 2, 3, 4, 5. So look at it this way. Isn't it the same thing when you have multiplication of exponents? Isn't it the same thing if you take these top numbers here, take this one and add it to this one and add it to this one? Let's see. 2 plus 1 is 3. 3 plus 2 equals 5. How many do we have here? 1, 2, 3, 4, 5. Isn't that the same thing? This works when the base number is the same. When you have the same base number, okay? And once you do that, then you can just solve it. So let's remember how to solve it. If you don't have a calculator or you prefer to use your brain, which I'm used to doing, and I love math, so I do that. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. And we have our answer. So that wasn't too bad, was it? No. Just remember, when you have the same base number and you have exponents, you can just add all the exponents up together, and that'll make it easier, okay? It may look difficult, but you can make it a lot easier. Now here's another way we can use exponents. We have a problem. 2 to the 5th power times 1/2, or 1 over 2 to the 3rd power. Now, if we write this out the long way, now we do have the same base number, which is good. That makes it a little bit simpler to do. So let's write this out. I'm going to have to go a little bit lower here. 2 times 2 times 2 times 2 times 2. Let's make sure we got them all. It's to the 5th power. 1, 2, 3, 4, 5. We do. And then we have, you know what I'm going to do? Well, no, I'll wait and do that. We'll do 1 over 2 to the 3rd power. 1, 2, and 3. Let me put a little line right here so you don't get confused. All right. Now, we've talked about fractions, so I'm going to use fractions before I finish this. So if you divide 5, or you have 5 over 5, that equals 1 whole, right? Because it's the same thing. You're just dividing something by itself. So it's also like saying 1. So if you divide this part by 5 and this part by 5, you get 1 when you mark it out, right? So it becomes 1 over 1. So let's go back here. If you have 2's at the top and 2's at the bottom, can't you cancel them out? Wouldn't this 2 and this 2 equal 1 whole? It's kind of like canceling each other out. And you can do it with the others, but it has to be top and bottom, because you can only take, you have to cancel 1 whole, okay? So this one and this one. And if you see what's left over, how many 2's are left? 1, 2, okay? So now what do we have? So now it's 2 times 2, and the only thing left is that 1, which, because all of these together act as a whole, and all of these act as a whole, it's just the number 1 over 1. It's a whole. If you want to put it there, you can. You can put the 1 there if you want, but it won't make a huge difference. Now, doesn't it seem like we just subtracted these and these out? For example, if we were to, with this this is going to be more like division just because one's top and one's bottom. So 5, the exponents are 5 and 3. So you took 3 away from this 5 here, and you have 2 left. Isn't that what we have here? 2 to the second power. Isn't that what's left? So when you're doing this problem, it's not multiplication, because if it was multiplication, it would be this number and this number. But we're actually doing numerator and denominator, where we're going to cancel things out. So in this case, it'd be like subtracting the exponents. Remember up here, everything was multiplied and it was added together because you're multiplying. But when you're dividing it, because this is on the bottom, you subtract this exponent and this exponent, okay? I hope I didn't confuse anyone. If you feel confused, this is a time to make sure that you get some help, some more help with this, okay? But hopefully you understand. So we have 2 to the second power, and we have it written the long way here, 2 times 2, which is 4. And you can do the 4 times 1 if you'd like. It still is going to be 4. And so our answer is 4. All right? So now that we've gone through a few, I'm going to put up just a couple of problems, or a few problems, and you can see how that works for you, okay? All right, so now we're going to do some problems. If you would like to try these before we do them together, go ahead and pause your screen now, and you can do that. All right, let's start with problem 1. These are all division problems. Now, hopefully you remember what I said about division. Are we going to add or subtract these exponents? Hopefully you said we're going to subtract them, because this is division, not multiplication, okay? So if we were to just take the, we can do it the long way first if you like. 2 6 times, for people that like the visual. And actually I'll do it this way, divided by 2 to the second power. So 2 times, because they have the same base number. And we can just cancel out. That's 1, and that's 1. So we have 4 left. That's one way to do it. But I encourage you to try to do it the shortest way, which is just going 2 and putting the exponent 6 minus 2, which equals 4. Okay? And so we'll write it again just so that we'll have it the right way. And then, if you want to do it the long way, you can 2 times 2 times 2 times 2. If you like, I'm going to use this one that we have already written. 2 times 2 is 4. 4 times 2 is 8. Oh, I shouldn't have used that one, but let's just act like I didn't. Or, I'll redo it for you guys. Make it just right for you. It's going to look a little smudged, but we'll get it done. So 4 times 2 is 8. And 8 times 2 is going to be 16. And so our answer will be 16. Okay? I hope that's what you got. Now, what would we have done differently if that was a times, a multiplication symbol instead of a division symbol? We would have added the exponents. Please remember that. Because when you divide, you're going to be taking something away, more than likely. When you multiply, you're making things bigger, okay? So that's why you would add with multiplication. Now, next one. We're going to skip this version because this is now another problem. You've already done a few. So we're going to do it the short way. Since they have the same base number of 3, we're just going to use these exponents and we're going to do what? Subtract. 10 minus 4 minus 1 equals. So 10 minus 4 is 6. 6 minus 1 is 5. So our answer is going to be 5. Let's rewrite it. Get a clean version, which is 3 to the 5th power is how you say that. And so now we can actually solve the problem. Calculator is the really shortcut, but I'm going to use my brain. And I'm going to write it a little bit differently this time, just so we don't forget that dots mean the same thing. So let's make sure we have 5. 1, 2, 3, 4, 5, and we do. 3 times 3 is 9. 9 times 3 is 27. Make sure you know your math facts. 27 times 3 is, I'm going to do it in my head, I think. No, I'm not, because I want you guys to see the work. I got to make sure you see what's going on. It's 81. I tend to do that. I try not to take too many shortcuts because I'm supposed to be showing you guys how to do it. Okay? And 81 times 3 is 3. 8 times 3 is 24. That's a pretty big number. 243 is the answer. That's what exponents do. When you're multiplying numbers by themselves, the numbers get bigger quicker. Just look. That 2 ended up having 16 as the answer. Okay? Now, another division problem. So what are we going to do? You guys should be getting pretty good at this. Oh my goodness, the base numbers are not the same. We can't do this. Oh my goodness, I don't know what to do. So what you can do is write it out the long way. 10 times 10 times 10. That's how many times we're supposed to put 10, right? And now how many times are we going to put this 2? You think you can solve this? This one's a little different. So you might see a little pattern here. Okay? So here's what you can do. Because they all are the same, you can actually simplify them somewhat. Find factors that are the same. So what factors are the same between 10 and 2? Is there a factor? I think they both go into 2, right? So this one would go into 2 how many times? 1 time. And how many times will 2 go into 10? 5 times. So couldn't you do that over here also? Same thing, right? As long as you do the same thing to each one. So you could say 5 here. 5 here, 5 here, 1 here, 1 here, and 1 here, right? Doesn't that make it easier to solve? It does. As long as you're doing the same thing, you're using the same factor for the top and the bottom, it'll work out, okay? So now what do we have? 5. Which the 5s are here, 5 to the 3rd power. We didn't change the exponents. And 1 to the 3rd power. Okay? 1 times itself is how much? 1, right? So usually when you see that 1 there, you don't have to worry about the 1. We're just going to act like the 1's not there, and we're going to put 5 to the 3rd power. Now let's solve it, okay? We're going to use our brains. 5, 5, and 5. Oh, really need that. So 5 times 5 is what? 25. 25 times 5 is what? Oh, do you know? Do you really, really know? So I'll do it over here so you can see the actual work. 5 times 5 is 25. So you put the 5 here, carry the 2, and then 5 times 2 is 10, plus 2 is 12. So our answer is 125. You see how you got that? When you didn't know how to do it, you're like, oh, wait a minute, it's not what I'm used to. But then you start looking for patterns, okay? And that's your pattern right there. When you write it out, you can see it there, or some people might have seen it before that. I hope that's what you got if you tried it for the first time. If you got that right, that's awesome. If not, it's okay, because I kind of threw you into that one, okay? Now, let's try another one that does not have the same base number. They have different base numbers. And they don't have factors that are the same. There's no factor that goes into both of them. So we're just going to have to do it the way that it is, okay? Let's do it. Here we go. 3 times 3 times 3 and 4 times 4 times 4, okay? So I'm just going to start with the top, the numerator, and do 3 times 3 is 9, and 9 times 3 is 27. So I'm going to put the 27 right here. Now, let's do the bottom. 4 times 4 is 16. That's an ugly looking 16, but we'll take it. 16 times 4 is, just in case you don't know, here we go, 16 times 4. 6 times 4 is 24. So put the 4 there and bring the 2 over. 4 times 1 is 4, plus 2 is 6. So that would be 64. And that's your answer. And if you can find a common factor for them to be divided into, you can simplify it. But I will take this for now. This is a good answer. Okay, this is the answer we're going with. So I hope that wasn't too difficult. Or if you were tripped up a little bit, it's because of the first time that you've done it with me at least. And you can definitely have more practice with it. I'm sure you can find some other problems that are just like these between your teacher and your rep family. And I hope that you continue to practice, because these skills are going to build on some of the more advanced problems, like when you get into algebra and other things, you're going to need to know how to do this, okay? As I always say, it's important to exercise your mind as well as your body. And I hope to see you soon.
Please be sure to like, subscribe and share this video. It helps us reach more people who could use our help.